help you figure out what the graph transformations are. Okay. All right, so let's get started. Looking at the graphs of basic functions up here at the top left, we have a constant function that's just a horizontal line. Then we have the identity function. This would also be called like a linear function. That's what I would call this, a linear function. Then we have absolute value function, a quadratic, which is f of x equals x squared, a cubic, which is x cubed, and then square root, then a cube root down here, and then these two we use less often. So the reciprocal and the reciprocal squared we use less often. And then let's take a look at our graph transformations. We have 10 graph transformations. We're going to focus just right now on these first 4. These are called translations. All right, so the first 4 are called translations. The next 2 are called deflections. And then the bottom 4 are shifts. Sorry, let me say that again. Stretches. These bottom 4 are stretches and compressions. So stretch, so it's going to get bigger. Compressions, where you're like flattening it out, get smaller. But we're going to start with these first 4 up here. So I'm going to zoom in on them so you can see them better. So we have first graph transformation says f of x plus k. What this means is that if you are adding a number on the outside of the function to the end, then you are going to shift the graph up k units. So for example, if you had something like this, I'm going to pull one of my basic functions off of that graphs of basic functions list. So let's say I had like y equals x squared. So if I had y equals x squared and then I add a number to the end, then that's going to shift it up 7 units. So basically I would take this graph of a quadratic right here, and then I would take the graph and shift it up 7 units. All right, so then it would no longer go through the origin, it would go through the 0.07. Now, very similar, if I subtracted the number from the end, it's going to move it down. And then if I add a number on the inside, so let me show you what that would look like. Adding a number on the inside would look like this. So notice how it has those parentheses in there. That kind of gives you a heads up whenever you see like parentheses or something like absolute value. That will give you a heads up that it's on the inside. So if I add a number to the inside, it's going to move it to the left. That's kind of counterintuitive. Like you might think you're adding a positive number, shouldn't it move it to the right? This one is a little bit counterintuitive compared to these first 2, because like I said, adding a positive number on the inside is going to move it to the left, whereas subtracting a number on the inside is going to move it to the right. And the reason that is because if you take this inside part here, set it equal to 0, that gives you x equals -7. So again, it's moving it to the left to account for the fact that this really represents a negative number. All right, so let's look at an example. Here's our first example. They're pretty basic, really. The questions in this section are not terribly difficult. I didn't tell you all the section name, but section 4.1 is called Transformations of Functions. And this here at the top is just those first 4 graph transformations, those translations. All right, so transformations of functions. So our next test is going to be over chapter 4 and chapter 6. And we're going to try to cover all of chapter 4 and all of chapter 6, but I'm going to, adjust the schedule as we need to so that we make sure that we keep our test stay the same. So we're sure going to have a test on November 19th. All right, so let's take a look at our first question. Really basic. On this one, it says, consider the following function. F of x equals, then we have x minus 2 in the parentheses, all raised to the 3rd power, so x minus 2 cubed. It says, determine the more basic function that has been shifted, reflected, stretched, or compressed. So basically what you do here is you look at your function, you say, okay, what's the defining feature, the defining characteristic that I see in this function? When I look at this, the thing that stands out is that third power, so the cube. So the thing that stands out to me is that cubed. So I'm going to look at my graphs of basic functions, and I'm going to see, okay, which one matches up best with this? So that would be this cubic function here, x cubed. So that's all you have to write. F of x or y equals, I'll do y equals x cubed. So that's the basic function that you start with to obtain this function f of x. All right, and then of course we can see what's happening here. We're subtracting 2 on the inside. So then you would go, if they asked you to list the graph transformations, you would go and look at your list. So you say, okay, I'm subtracting the number on the inside, that would be here, subtracting the number on the inside, so it would be shifted right. So if they asked you what transformations have been performed, you would say it's been shifted to the right 2 units. All right, but we're just going to graph this. So if you don't have a graphing calculator with you, I did bring some today. If you want to grab one. And then I'm going to go to my y equals screen, and I'm going to graph this. I'm graphing this function up here at the top, f of x. So x minus 2 cubed. I'm going to be really careful, make sure I put parentheses everywhere they have parentheses. X minus 2 cubed. Make sure you're in the standard window, like -10 to 10. So I'm just going to go window. Everything looks fine here. If you're not in that -10 to 10 window, just go to zoom and then zoom standard, which is 6. And there we go. You can see it looks just like that cubic function from this sheet. So here's that cubic function. And instead of going through the origin, you can see it's been shifted to the right 2 units. All right, so we're just going to sketch that. On the test, I wouldn't ask you to draw a graph, but you could use the graphing calculator to help you figure out, what the graph transformations were. All right, so just sketch that. All right, so again, if you get to the test and you're like, I don't remember how to use these graph transformations, you could just graph it on your graphing calculator and then, write down what happens. All right, so next we have reflection. So we're looking at these 2 right here. So these 2 reflections. All right, so if you're multiplying by a negative on the outside, that's a reflection across the x-axis. So here you have a negative on the outside. If you're multiplying by a negative on the inside, then that's a reflection across the y-axis. All right, so negative on the outside is the x-axis, negative on the inside is the y-axis. And let me just show you some examples of what this might look like. Let me find my sheet. All right, so here's some examples of what a negative on the outside would look like. So negative on outside. You might have something like f of x equals negative square root of x. All right, so there's an example of a negative on the outside. This one's pretty easy to see compared to a negative on the inside, which would look like this. The ones that are a little bit harder to see are things like a cubic function or a quadratic function. So here would be a quadratic function with a negative on the outside. And then here would be an example where the negative's on the inside. All right, so when you're thinking about things being multiplied by a negative on the inside or numbers being added or subtracted on the inside, always look for those things like parentheses or things like square roots or absolute value symbols to help you figure out, is this happening on the inside or on the outside? All right, so let's look at an example with a negative with a reflection. So anytime you see a negative you want to think reflection. All right, so here's our function for number 2. So consider the following function, f of x equals negative square root of x minus 1 plus 4. Plus 4 is on the outside of the radical. So part A is just determine the basic function that's been shifted, reflected, stretched, or compressed. So you would say, what's the defining feature of this function? What stands out the most? So what do y'all think stands out the most about this function? Like on that last one, it was the cube, the x bar of 3. The square root, yeah. Yeah, so that square root is what stands out the most to me. It's got the square root in it. So then that's going to help you figure out, okay, I'm going to go to my basic functions sheet. Which one does this match up with the best? That would be a square root. I don't know why this one doesn't have a line over the top of the square root. You can draw that in. All right, so my square root didn't have a little hat on or whatever. All right, so this one matches up best with the square root of x, so that would be our answer for part A. All right, and then we're going to compare these two, because the next one says, determine how the basic function, y equals square root of x, has been shifted, reflected, stretched, or compressed. So we're going to compare this function here with the function we were given and see, what transformations have been performed on this function. So always start on the left and move towards the right. So starting with this negative, it's on the outside, so we know a negative means it's a reflection. But since it's on the outside, is that a reflection across the x-axis or the y-axis? Good. Reflection across x-axis. And again, we know that because of our sheet here, it says if a negative's on the outside, you reflect across x-axis. All right, so we've taken care of this first piece. Now we're moving to the right. We see, okay, we're subtracting 1 on the inside of the radical. All right, so what happens when you subtract a number on the inside of the radical? It's definitely a shift. Shift which way? Yeah, we are going to shift up 4, but we are going to shift to the right 1. Good. Shift right 1 and then shift up 4. So does everybody see where that shift up 4 part comes from? That's here at the end. So we're adding 4 to the end. That's going to shift it up 4. How can I change this just a little bit and make it shift down 4 instead of up 4? Yeah, change that 4 on the end to a negative 4. So if all I would have to do is just change that to a minus sign and it would shift it down 4 instead of up 4. All right, so all you're doing on these, this will be exactly what I ask you to do on the test, part A and B. So all you have to do is compare it to your little sheet, figure out, where does this match up. So again, adding 4, adding something to the end matches up with that first one. Subtracting a number on the inside matches up here. So we need to shift right. Now, another option, something else you can do, is just graph this in your calculator, and that should help you identify what the transformations are that are occurring. So go to your graphing calculator, go to your y equals screen, type in your function, negative square root of x minus 1, then get on the outside, do a plus 4, and then graph that. So you can see it looks like a square root graph, but it's been flipped upside down, so that's a reflection across the x-axis. It's been shifted to the right 1, so it originally went through the origin. It's been shifted to the right 1, then it went up 1, 2, 3, 4. All right, so that's one way you can check your answer, or if you just get lost when you're on this problem on the test, you can just graph it and see if you can identify the transformations from there. All right, so my guess is that I'll have something that looks really similar to this on the test, and I could even change this just a little bit and do something like negative x minus 1 cubed plus 4. And it would be the same exact graph transformations, just the basic function would change to y equals x cubed. So something really similar to this. And maybe I just change the basic function. All right. Now we got to look at what I would say is like the more complicated transformations, which are vertical stretches and compressions, and then horizontal stretches and compressions. So up until now, all the transformations that we've looked at have not changed the shape of the graph. These 4 transformations can change the shape of the graph. So what they're going to do is they could take a graph like this, for example. We have a quadratic function, a little parabola. And a vertical compression would be where you take both ends of this and then just smash it together. So instead of being like a U, it would become, smashed vertically. It would look like that. Does that make sense? If you compressed it vertically, it would get, the U would get wider and wider. So let's take a look at each one of these. I'm going to refer to your sheet because I think these are a little bit easier to understand than the way the book writes them. So if you're multiplying by a whole number on the outside, that's this one right here, multiplying by a whole number on the outside, it's going to stretch it vertically by a factor of whatever that number is. So if this was something like, let's say y equals, we'll do f of x equals 2 times the square root of x. All right, so that's an example where you're multiplying by a whole number on the outside. All right, so this would be a vertical stretch to the graph of y equals square root of x. If you multiply by a fraction on the outside, that's going to compress it or shrink it vertically by a factor of whatever the denominator is. Now, this is kind of specific because in this example, you have to have 1 in the numerator of your fraction. So all the examples that I give you will have 1 in the numerator of the fraction, but if they give you something like this, say like 2/3 times square root of x, then you would have to rewrite that fraction so that it had 1 in the numerator, which is kind of annoying. But all the examples that I give you in this class will have 1 in the numerator. All right, so if you're multiplying by a fraction, the outside is going to compress it vertically by a factor of whatever the denominator is. Right, and then here's our inside operations. If you're multiplying by a whole number on the inside, it's going to compress it horizontally, so it's going to smush it in from the sides by a factor of whatever that whole number is that you're multiplying by. And then if you're multiplying by a fraction on the inside, it's going to stretch it horizontally by a factor of whatever the denominator is. So let's look at some examples of this. I typically don't put any of these on the test, but the vertical stretch isn't too bad, so that's what I have an example of here. It says consider the following function. F of x equals -3 times x plus 2 squared. Trying to pop this up. Alright, so -3 times x plus 2 squared minus 1. Right, so the first thing you got to figure out is what's the more basic function that we've shifted, refracted, stretched, or compressed here. So what stands out the most about this function? What do y'all think? Yeah, the squared. So you would say, okay, well, I know the squared is probably going to have the most effect on the function. So you would go to your graphs of basic functions and say, okay, which one does that match up with best? That would be this quadratic function, y equals x squared. So that's the more basic function that we start with. In an old textbook that I used, they called this like the parent function. So you could think like, okay, this was the parent, and then some changes happened. Some things were a little bit different, and this is like sort of like the child. So this is the parent, this is where it started, and this is the child. So now we have to list the graph transformation. So we're going left to right. So start with this negative on the outside. A negative on the outside, that's a reflection. The reflection across which axis? X. Reflect across X axis. All right, and now a 3, we're multiplying by a 3, a whole number on the outside. Good, stretch vertically. And it's important that you put, like if it's vertical or horizontal, stretch vertically by a factor of whatever the number is. So in this case, 2. Stretch vertically by a factor of 3. All right, so we've taken care of the negative and the 3. Now moving to the inside of the function, we got a plus 2. How is that going to shift it? Good, shift left. Shift left 2 units. And then minus 1 on the outside. Good, down 1. So shift down 1 unit. This will be exactly what you do on the test. I just probably wouldn't put this vertical stretch in there. So, but these 3 are totally fine for the test. And then we'll graph it just to see, make sure it matches up with our list of graph transformations. Let's see, go to your y equals screen, type in your function, negative 3, x plus 2 squared minus 1. All right, and it's supposed to, again, reflect across the x-axis, so it should look like a parabola, but upside down. Stretch vertically, and then shift left and down 1. Yeah, that looks right. It's hard to see the vertical stretches and compressions. Sometimes it's easier to see them if you put like the original function in there. You can see like how this one's a little bit more narrow than this one. So you can tell it's been stretched. But yeah, that looks like it matches up. It's flipped across the x-axis. It's been shifted to the left 2 and then down 1. So again, that's a good way to check your answer for the test. All right, so I'm going to sketch this graph. All right, so within the third quadrant down here. Okay. I have one more, and then we're done. This last one, I really like this one. I think it's an interesting question, but I typically don't put this one on the test. Now, you'll all have a question like this on the homework, and just a heads up, it'll never have any kind of like vertical stretch or compression or horizontal stretch or compression on this one. So you don't have to worry about the stretches or compressions on this example. It says, consider the graph of g of x, so that's this function here. Trying to zoom in so you can see the directions better. Write a formula for g of x that describes the transformations performed on the basic function. Right, so here we look at this graph and you would say, okay, well, I'm going to look at my graphs of basic functions and see which one does this most resemble. So which one does this most resemble? Square root, yeah. Yeah, so definitely that's the more basic function that it comes from. So we know that it comes from the graph of square root of x. It goes over 1 and up 3. So to the right 1 and then up 3. So you just compare that to your graph transformations list. Okay, if we want to go right 1, we need to subtract a number on the inside. So subtract 1 on the inside. So that would be, this one's named g of x, so we're going to say g of x equals square root of x. Move it to the right 1, we subtract a number on the inside. And then what would we do to move it up 3? Plus 3, and where do I put it? Good, on the outside of the radical. Now let me just show you one thing that they sometimes do in the homework. It's really annoying. I don't know why they do this. They will sometimes put this plus 3 in the beginning. So they'll write it like this. 3 plus square root of x minus 1. So just know, if you see it at the beginning, just rewrite it and put it at the end to make it better match up with our graph transformations list. I don't know why they do this. I have no control over when they put the number. Sometimes they'll put it at the end, sometimes they'll put it at the beginning. So just know, if they have that constant in the front, just go ahead and move it to the end to make it better match up with what we've done. Let me stop the recording, and then I'll talk about